Welcome everybody. Today I want to talk about this formula. You can check out the left side of the formula. Now the left side, what I've done here is you basically try to sum up the numbers, the integers starting from 1, 1, 2, 3 up to certain kind of integer n. And obviously n can be any positive integer here. So after summing up all the first n integers, you try to add extra integers by going backward from n. So you see n as the peak. Now you're trying to add extra integers starting from the one lower than n, which is n minus 1. So you try to add it back, n minus 1, n minus 2, and so on. So all the way down to 1. And this sum, you try to add everything just like what I said there. The sum on the left side is exactly the same as n squared. It actually looks like a pretty simple and amazing formula. And in this video, I'm trying to give you a simple explanation why it is true just by simple combinatorics. Anyway, we can try to give a simple example first, just to show you why it is true. So now the example I pick is n equals 4. So the left side, what is the left side? The left side is the same as 1 plus 2 plus 3 plus 4. And then you add the numbers backward, plus 3 plus 2 plus 1. You try to do it pretty easily in your mind. The answer must be 16. So pretty amazingly speaking, if you haven't seen this formula before, you should still be able to get the 16. Should be the same as 4 squared, which is a simple illustration why the formula in the red box is true. So I want to give a simple explanation why it is true, essentially for all n. Please look at this picture, everybody. Can you tell me the number of balls here? This total number of balls is 16. Or the other way of thinking, basically it's a 4 by 4 square, and essentially there's 16 balls. Anyway, now I try to count the number of balls here by a different manner. The way I do it is the following. What I just did was like I partitioned the number of balls here by using such a way of circling the balls inside different red boxes. And now all together there are 7 boxes here. Obviously they include a different number of balls. You try to do the counting yourself. For the first red box, there's 1 ball. The second one has 2 balls. The third one has 3 balls. And the next one, you basically did it yourself. It's pretty easy to see that. Essentially, I'm adding 1, 2, 3, 4, and then back there 3, 2, 1. So now it's pretty clear that obviously that this sum of the number of balls here must be 16 because we're talking about the same set of number of balls here. So basically I give you a simple explanation by puzzles just why this sum must be the same as 4 times 4. Okay, now this picture is really just about the case when n is 4 and I did such a partition. So the basic reasoning is that I basically choose 2 ways of counting the same number of balls here. So now I leave you a simple exercise. Can you tell me why the formula is true? Why this formula is true? Obviously the way to do it is you can try to put n square balls in the n by n manner in a square, and you basically did the same kind of partition just like what I did in the previous picture, and you can easily see that this formula is true just by this simple picture. And the way to do it was you count the number of balls in 2 different ways. And basically that's the end of this video. Thank you everybody.